Just wait. It says setting up your webinar or custom done redirecting. Okay. We have started the live stream.
Okay.
And
can you see my screen now?
Yeah, we can see.
Okay.
Let me just short introduce you, Dr. Canberk, and then you can start. Hello everyone, and today we are continuing our celebrated Connecting Experts webinar series as IEEE Region 8 YP subcommittee. And today we are organizing a webinar entitled AI-driven digital twin networks with IEEE Turkey YP group. And today our guest, our speaker is Professor Dr. Berk Canberk, who is the head of the Artificial Intelligence and Data Engineering, Artificial Intelligence Center at Istanbul Technical University, Turkey. And he is a young but very successful and celebrated professor. And he has already awarded with many awards, best paper awards, for example, when we consider Infocom. Infocom is one of the most prestigious conferences in communication, and also he has already won some other awards. And it can take a few minutes, so I will skip those numerous awards. And now I am leaving the stage to Dr. Canberk to give his exciting speech to us.
Okay.
Welcome to our session, and thank you very much for accepting our invitation for the webinar. We are very glad to host you, Dr. Canberk.
Okay, Ömer, thank you very much for this nice and concise presentation. It was concise, don't worry. So, and I'm really happy to be here today. I will talk about myself just like a few minutes with some slides, but I am really thankful that we have this conversation today, and hope to discuss with all of you, including all the members that are listening to us now offline, if you don't have time, about all these new technologies regarding the digital twin networks. So let me just start. As he said, I am from Istanbul Technical University within the Department of Artificial Intelligence and Data Engineering. I am also the director of the Artificial Intelligence and Data Science Research and Development Center, IEEE, which is abbreviated. I have some other administrative duties, including being the vice dean of research and development. I am also being an adjunct professor within the Department of ECE, like Electrical and Computer Engineering in Northeastern University in Boston. As I said, we have several other administrative duties as well as some services, and I am an IEEE senior member, and we have some awards and everything, but I will not go into details about those things. So let me just show and introduce you with the real heroes in my research, which are my lab members, my current lab members. All of them are really working hard and in order to build up research in our group. So I have more than 10 people, like BSc level, master level, and PhD level. And mostly we are working on the two things, let's say two subfields. One subfield is the smart network management of cyber physical systems. And the other field is AI-enabled network control systems. So cyber physical system itself and the network within this cyber physical system. So we have two, not that separated actually, but some kind of two branches under cyber physical systems and network automation area. We have a chat. Ömer, are you looking at this, or should we have a chat?
You should
okay, I think, yeah, I think this was your thing. Okay. So when we come to today's talk, probably it's gonna take like 35-40 minutes. I mean, I don't know how many of talks I have been given for the last 3-4 years, and the shortest, the most efficient. This is the thing that I got from the talks. So I wanted to make it as short as possible, like in maximum in 40 minutes max. We are going to be done, but of course I will just try to introduce you what is it and why we are doing this, some kind of basic research questions. So we need to discuss really more about the deep insight about this digital twin networks. So I will introduce the DT and DTN as digital twin networks, the marketplace, as well as the relationship between DTN and the 6G and the development timeline. Then I'm going to switch to some design issues where I will really briefly describe you how we can build up a digital twin. It will be a brief one because it's a huge area actually. So I will try to just give you some small but efficient information about this design. Then I will talk about some applications, including like supply chain applications, predictive maintenance, warehouse management, power grid management, healthcare. Then when I'm going to stop, I will also talk about a really nice local representation about digital twin and the digital twin factory and the industrial digital factory, which is MEXT in Turkey, in Istanbul. And I'm going to conclude my presentation. Okay, so these in these slides, whatever you see are not my words. Okay, so we just try to get some information from several resources in order to get an idea about what's a digital twin. And if you look at Wikipedia, you see a digital twin definition as a virtual representation that serves as a real-time digital counterpart. If you see another definition from other source, you see again virtual representation. So you keep seeing the same words again and again, either in the digital twin definition and digital twin network definition. What are these repetitive words? The repetitive words here are the visual representation and real-time. Actually, these are the two catches under digital twin networks. So we are representing the physical world as a virtual representation, which has been already done in simulations. But the other things that we do with digital twins and digital twin networks is that we are in real time. So whatever you see in the real world, you should see in your simulation right now. Okay, so I will show you the concise and the distinct separation between digital twin and simulation, but for now, as far as we see, the digital twin is the virtual representation of an object of a system, and we try to be as real as possible, as real time as possible. In terms of networks, so actually the only difference is that we are not just simulating a single object, but we are just simulating a connected object. So we have a network, all these elements in the networks are connected to each other. So when it comes to the challenges, all the network challenges, including the reliability, throughput, all the quality of service challenges are also available in digital twin networks. That's the idea actually. Here you are, the main difference between the simulation environment and DTN. The main reason that I want to put this is that anytime we are talking about digital twin, this is the first question that I am being asked. Like, so what's the difference between DTN or DT and simulation? So let me briefly discuss about this. In a simulation, we are doing a static modeling, whereas in DTN, we have an active modeling. In the simulation environment, we have a non-real-time data, whereas in DTN, we have a real-time one. One-way flow of information in the simulation, whereas in the DTN, we have two-way flow. In the simulation, the most important catch is that we are trying to see what may happen in the system, whereas in DTN, we see that what may happen, but plus, in addition, we are also seeing what is actually happening in the system. This is the most important catch actually. It can be theoretical in simulation, whereas in DTN it can be specific and actual. I'm in terms of scope of usage, both of them can be narrow or both of them can be quite wide. This is, I mean, in my honest opinion, I wrote it here narrow and wide, but we can change it. Like, or both of them can be quite wide. Today we see really nice and wide simulations as well. But in simulation, we are less costly, whereas in the DTN, we are more costly. And in the slides, in the figures that you see below, one is taken from TV Global, and the other one is from MATLAB, from MathWorks. So what I mean, on the left-hand side, it's a complete simulation, whereas in the right-hand side, we are seeing some kind of a digital representation of a real object, of a real system, which are the pumps in that case. Okay, so this is the digital twin market size that we see. Like we are trying to, we want to see an increase in the digital twin market, like maybe more than 50 billion by 2026. So we have several different types of digital twins, like part digital twin, product digital twin, process twin, system twin, and they have different applications like product design and development. The machine and equipment health monitoring, predictive maintenance, of course, which we are going to talk about in 15 minutes. In terms of technologies, of course, IoT and industrial IoT, IIoT is one of the first technology that digital twin is implemented into. We have AI, ML everywhere. Of course, we are trying to build up a brain into digital twin, and the brain is built up by the aid of artificial intelligence and machine learning. Blockchain is in the scene now. We have seen several digital twin-based blockchain technologies. AR, VR, and these mixed realities are also one of the technologies of digital twins and digital twin networks. Of course, big 5G and big data analytics are also the technologies that we are following in terms of digital twins. We have several vertical industries, including aerospace, healthcare, telecom, electrical and electronics manufacturing, energy utilities, and many others that we can count on. Oops. So the market size, as we continue, is quite growing, as you see in the picture. By the way, you can see the sources that I am taking. I am taking those slides. And as you see now in 2021, we have like several industries already going on with the digital twin, including the automotive and transport being the most focused industry in terms of DTN and DT. But this is growing and growing. For example, the manufacturing in 6-7 years, the market size of the manufacturing will be growing according to this forecasting. Healthcare and life science is another way to go. Energy and utilities, as you see, is growing and growing. Agriculture, retail and consumer goods. In all these different types of industries, digital twin will gain lots of importance. So we have the advantages for 6G networks. As you see, we have like this famous formula, like bit per second, per hertz, per meter square, per joule. So in every sequences of this formula, let's say, or is a phrase, let's say, not a formula actually, but it's like a phrase, like a sentence. We have increase in the speed, we have increase in the spectrum, like not an increase in the spectrum itself, but increase in the usage of the spectrum or effective usage of the spectrum, coverage, energy, and cost. And digital twin is everywhere here. So whenever we have a physical and logical state, the observed state used to configure the functional part, and after the decision, the new state is estimated from the functional one in order to come up with the new decision. Here you see some kind of a representation. So you have observation of real entities in the blue one, and at some time this real observation will push me to give a decision in the digital twin part and in the brain part. And using this simulation, using this environment, using this decision, I will just manipulate and actuate changes to the twin, to the physical twin. This is the development timeline of the digital twin. Everything has started in 1970s. And then we have Michael Greaves in 2002 with digital twin theorization, product management in University of Michigan. Then, as you see in the product timeline, we have NASA, US Force, and several other different institutes and agencies that are implementing digital twins. When we come to these years, to today, nowadays, application digital twin is mostly in industrial IoT and the IoT. Okay, so let me briefly continue by giving you the digital twin design in depth, some basic information. Here, since I am a communication person, since my research area is focused on the networking part, I'll give you some information regarding the network challenges. Here you see on the right-hand side, you see a figure taken from one journal paper. And here you see the physical world. This has already been discussed. I mean, we have several technologies here, including LoRa, Bluetooth, Zigbee, etc. In the virtual world, we have the V2V, which is virtual to virtual communication. And we have the infrastructure here, 6G and 5G and internet. And we have also P2V, which is called physical to virtual, which is the most important communication challenge that we have seen in the DTN part. We have several metrics, already existing metrics, of course, like reliability, latency, capacity, and connectivity that you can also see in the digital twin network technologies. And we are trying to adjust and manipulate these 4 metrics at the same time. We try to accurately model the twins. Here you see another picture taken from another journal paper from 2020. Here you see the physical object in the left-hand side, and in the virtual part, in the virtual space, you see its representative, the logical one. And here we have like the API, and this API is programmed such a way that you are going back and using the historical data, of course, you are directly representing, you are one-to-one, you have a one-to-one representation of your digital twin. Here you see like a function-based representation. The physical object and the logical object are directly mapped to each other. Several things comes into the scene here. Most important challenge that you see in digital twin networks is synchronization. So you have to be synchronized. Actually, synchronization has been an important challenge for the last 30 years, maybe in our networking world. But with DT and with DTN, it becomes a separate importance, such that if you cannot be that synchronized with your physical device, physical entity that you want to represent in, the real meaning of digital twin is lost. So the synchronization should be really in the second-ish of unit in order to be like be accurate. So it's not an easy task to do, of course. So you have to improve the technology a lot. And the TCN, like the time-sensitive networks, comes into the scene here. It's another topic. Maybe with Ömer we are going to talk, and we will have another like a talk with that. But TCN, like time-sensitive networking, is one of the area that we can find out several challenges for digital twin networks. Oops. Here in the DTN design and management, we have. If you look at the left-hand side, you see a controlling different logical objects in a DTN. Just follow the numbers. You start by 1, and the status you see in the application space. And if I want to change the status from S0 to S1, let's say, this status change it will be reflected to the virtual space. Okay, so you see here an S. This is the master replica of your real device. Actually, the device that you have here in the application space. And in the master replica, you are just trying to change the status according to the application space. You check the consistency. This will take time. This will need synchronization. This will need some kind of a scheduling and admission control mechanism. After checking the consistency, you check the status of the real object with 4. Then the job is not done. After changing the status, or let's say while changing the status of the real object, you are also giving information to the other spaces, other logical object in your virtual space, so that they are synchronized with you. As you see, you have a synchronization problem or synchronization issue when you have the P2V, where is my mouse? Where you have a P2V communication, as well as you have the V2V communication. Okay, so in both cases, the synchronization should be kept under consideration. On the right-hand side, you see the smart orchestration of DTs. If we need an orchestrator, as we have in the SDN, actually SDN was one of my previous huge topic that I was working on, like drone networks and like digital twin networks. In SDN, we always need an orchestrator in order to, as the name implies, orchestrate or manage or tune the virtual space. Now we have the same. We need the same guy in order to do the orchestration. Orchestrate what? Orchestrate the updates, the current updates of the virtual space, of the virtual logical objects. Whenever there's a change in the logical objects, someone should be care of. Someone should know this change, sudden change, and then we need someone to orchestrate such that the other entities also aware of the idea. So what are the other challenges that we may come through? All these different blocks requires a different seminar actually, but let me just try to, according to my own vision, of course, things may change according to someone else. We have like a physical data processing, because we have data uncertainty, data visualization, and high dimensional data and heterogeneous data. So we need some kind of a physical data processing. Of course, network is one area. Actually, we are just here in the networking part by giving the low latency and hyper connectivity. We need a really high computing ability. By this, we are also introducing edge intelligence, because as you see, we try to get informed about the changes in the virtual side and changes in the physical side as soon as possible. Apart from being technologically advanced, we also need to be as close as possible to the real environment. So then edge comes into the scene. If you can compute the new states as soon as possible in a closer environment, in a closer server farm, let's say, your decision will be conveyed to the physical world in a much sooner time. So we need to have some kind of edge intelligence in that sense. Of course, cloud computing and cloud intelligence is always in the scene because we need to gather this information. We need to just pre-process and do the job. So cloud is also in the scene. There is one area that I am not that good at too, which is like a 3D modeling in the digital twin, because we need to also represent the real world as accurate as possible, like in the DT, like in the 3D environment. So we need a DT modeling, like high precision modeling, not only in terms of technology, but in terms of visualization as well. And V2V is also has an importance here in terms of reliable information and high fault tolerance. To solve these different types of challenges, like that data processing challenge, networking challenge, computing challenge, visualization challenges, as well as the reliability challenges, of course, AI can be one of the solutions for that, including deep, like reinforcement learning or deep learning or machine learning. Communication standards that we are working on, like 6G or 5G and beyond, can be one of the solution in order to solve these problems. As we have just discussed, the cloud computing and edge computing are also are the solution in order to get informed and get the best from the DTN. Of course, optimization technique is another technology to discuss. Okay, let me just give you one real concrete example that, for example, the Microsoft Azure has the digital twin. MATLAB has some digital twin implementations. You can implement your own using using any programming language that you have. In order to design a digital twin, so you need to give some features to your digital object. So you need to give like property feature. You need to define a relationship feature. You need to grab some telemetry information, and you need to have some subcomponents. So you need to have like different types of features in order to design your 3D model. Microsoft Azure is one of the example, just one of the example to discuss this. We have we have several works going on and several projects going on in the digital twin, but one of them is related with the predictive anomaly detection for Wi-Fi networks. Here, imagine that you have in the real environment a real Wi-Fi device, and this Wi-Fi device connects several different users, including the mobile phones, laptops, etc. Just normally we have, but on the big picture, you see in the black screen, you see the digital representation of your environment. In this digital representation, you have routers. You have one router, sorry, as you have in the left-hand side here as one router, and two, like green and red in the real one. You have like 2 access points, and you have several users. What digital twin network does is as follows. We first design these like oval objects, like the circles. How we design it? By giving them several features, like property feature, like relationship feature, telemetry feature, component feature. After designing this, we start monitoring in real time what's happening in your world. Then if you need it, by making some queries, we are just interweaving the physical environment by the decision that we are giving in the digital environment. For example, imagine that you have a Wi-Fi access point, and you want to you want to just leave the network, or you want to admit new one to the network. So you are just activating some ports, or you are disabling some ports. This type of real-time decision can now be done in your digital twin representation. If you decide to just activate, deactivate, or increase the bitrate or decrease the bitrate of some ports, then we are using our digital twin to send the information directly to your physical one, so that we can have the direct communication in between. There is another example in the by MATLAB. You have some inputs. These are real inputs. I am building the digital twin, by obtaining and exploring the data, and I keep being fed by this sensor data. I pre-process it and develop the predictive model. The predictive model is in my laptop, in my digital environment. I have my physical environment already simulated. It's in the real life. So it's the pumps, for example, they keep working. Meanwhile, I can see this pump working in my digital environment, and I can also see a predictive maintenance algorithm, maybe, or predictive version of this already existing pump world, and then try to give new decisions. Okay, this also brings us the idea of data-driven modeling, which is not a new idea, of course. It has been true for the last 15 years, maybe. But with digital twin, it brings another. It has another meaning for us. So thanks to the data-driven modeling, we are not always. We don't have to go and put some sensors to the really sensitive areas in the physical world. If we can grab the accurate data information, if we have text file, or if we have categorical files, or if we have images in real time, if we have CSV files in real time, and then work on these simulations in the data-driven modeling, and then feedback it with the real-time data. So we are actually we can actually manipulate the real-time environment. So data-driven modeling is another way to go to access and to build up a real digital twin network. Networks is just an example, an example company or an example idea to done those simulations, to do the simulations. Sorry. Good, I'm in a good shape. So let me just pass to the last part by giving some examples, example application, like sample application. One of the sample application is supply chain management and control tower. So we can just design a control tower. It's just an analogy, of course, in order to enhance the visibility of short-term, mid-term, and long-term decision making. But how we do that? By just grabbing the current state history, by just taking task and case management, and then we can have decision support forecasting. Business intelligence, visualization, and dashboard are the thing to be done in that sense. Another application example can be from the supply chain management. You can build up this kind of simulation software not only in Azure that we have. You can use any other type of simulations like we have in Analogic. This is a supply chain dynamic simulator. And we try to visualize the network flow and try to see what may happen in the network and intervene in the network if needed. And one thing that we can generate with digital twin is that what if scenarios. We are trying to understand what if this happened, what if that happened. So by asking those questions to us, we are trying to build up the scenario. So in the supply chain management, we have demand forecasting, aggregate planning, and inventory planning. By just focusing all these different types of planning history, not only in supply chain, but also in several other technologies, you can design an accurate digital twin scenario. One other example is from predictive maintenance. Digital twin networks and digital twins are also used in predictive maintenance. Here you see an example in agent-based turbine operations from Siemens. Again, Analogic is used here, and we are trying to capture and forecast the system KPIs and identify the bottlenecks in the system. And again, run what-if scenarios and manipulate the system accordingly. SimCAT has some warehouse management utilities like data-driven warehouse digital twins. Here you have low-cost data storage and computing power. As you see in the figure, like all the forklifts that you have are actually the forklifts that are existing in the real world. So whenever a forklift driver, for example, stops his car for a reason, so you can see this movement change and then intervene and act accordingly. So we are trying to analyze the congestion. We are trying to reduce the congestion. We are trying to appropriately design all the sensor data to give new decision related to our environment. We can always do the digital twin of like an electrical grid in order to monitor and intervene to the day-to-day operation to understand the productivity and the consumption analysis of grid networks. It's an automated data and model synchronization that we can distribute across multiple domains to help the staff to manage the power flows or protection settings to meet demand without overloading the transformers. An interesting application actually that you are twinning the body like software as a medical service. You cannot of course twin the entire body, which is the most sophisticated system in the world, like the body, but you can just simulate, for example, some organs like virtual organs. Why do you do that? You are doing that to see the current reaction, the current activities of these parts, and if there is a chance to react accordingly under circumstances. Genomic medicine is also a way to go, or personalized health information, customized drug treatment, planning surgeries are other implementation that unfortunately I don't have enough know-how for the proceed this, but we will be more than happy to work together with medicine and the medical companies or the medical faculties to do those kind of research. It's a really interesting area to define like software as a medical service. We get to track and manage disease outbreaks to be better prepared in the response to, for example, COVID, or a spatiotemporal patient database for smart health cities. Last but least, we are trying to, let me show you what we are trying to do in this slide. Here you see an industrial digital twin factory in Istanbul in Turkey. This is the first digital hot galvanizing line. In the figure, in the picture, actually, it's a real picture. In the left-hand side, here in the left-hand side, you see the digital twin, and these two small pictures are the photos taken from Next. Here you see the factory itself, and they are discrete. They are continuous. They have a continuous production, and they are continuously monitoring this production line in order to monitor, of course, the real-time monitor and run what-if scenarios and intervene accordingly on the left-hand side. On the right-hand side, you see the digital hot galvanizing line, a real factory from T0 up to the Tn for the entire production line. You see a complete digitalized version. I think by this, I will be done. So thank you for listening to me. As I said, this is quite a huge topic. I just wanted to give you some brief information about how we can get familiar to digital twins and digital twin networks. If you have questions, I will be happy to answer them, or offline, whenever you are sending me a mail in my IT email or in my Nordistan email, I will be happy to answer to those questions too. Ömer, I'm done.
Yeah, thank you very much for this concise and great presentation, exciting presentation, in fact, because these topics are really interesting. People are talking about, and it was really interesting, insightful presentation.
Thank you. Thank you.
I'm just looking for the question. If anyone asks, no one asked just now. I just want to ask a few questions. The first one, can we return back to 17th slide?
17th.
Yeah, 17th. This one, yeah, this one. Here, as I see, there are some challenges: resource limitation and environmental dynamics. I say the resource limitation here. The resource limitation. Because of the resource limitation, the processing of digital twins becomes low or not. Could you expand that? What is the challenge in resource limitation in that?
Okay, yeah, nice part actually. As I said, this I mean all these lines can have a separate seminar, Ömer, as you can imagine.
Yeah.
In this resource limitation, we are talking about the resource itself in a data center, like a CPU, memory, or any type of network-wise resources like bandwidth limitations. In terms of CPU, you have a real challenge actually. Why? Because the data should be processed, should be pre-processed. In terms of GPU, you have a challenge. Why? Because I am not only talking about a simple categorical data here. You can have some pictures, you can have like real-time videos. And in that sense, the GPU, the graphical interface, comes into the scene. So this type of resources are limited. So you have to be really intelligent to design to how to manage these resources. In terms of network resources, like one of the most important network resource is bandwidth, of course. You don't, I mean, if you send anything, if you send everything that you captured from the real time, from the real world, your bandwidth will be quite full, like in few minutes. Okay, so you can just capture like gigabit level data. So you have to select, you have to be selective, and you have to select the information, the most informative data that is meaningful to you, and send this. So what type of challenges you have here? Moreover, we have, of course, challenges in terms of data compression. So here, what type of security that you have to implement in order to have a nice and concise and effective data compression, like header compression or data compression comes into the scene. So any type of this resource limitation are to be discussed in this sense, Ömer.
Thank you very much for that one. As I see, there are also many challenges, and of course we can expand that. But as you said, those are the topic. Those can be another webinar topics. So we can check that. And could you come to the 28 slides?
28.
8, yeah. Yeah. Okay. Here we talk about the digital twins for the medical applications, and generally when we consider medical application and AI, people talk about some ethics about that, or for example, when you consider data privacy or data privacy of the patients, or let me pull all the thing. I say that when people consider digital twins with the in the healthcare, do they really consider the ethics issues?
Yes. Not only in
Especially in Europe, because you know that Europe is very sensitive about that, the GDPR issues or some other issues. When you consider some personal healthcare records, or people become more sensitive, especially in the COVID-19 era, post-COVID-19 era. That is why I am asking this.
Yes, actually, another good one, Ömer. So, I mean, digital twin and ethics is also, I mean, not only in the medical sense, but in all the other application area, it has an importance. So we have to be really careful what to gather, what to collect, what to proceed, what to do the processing. So in this sense, we are talking about the monitoring the body, which is the most valuable data of everyone, of course. So probably this will be another like a topic to just before to discuss, since the person who should have the willing to give this information to a digital twin to be processed. Actually, I mean, you shouldn't like monitor someone's heart if he or she doesn't want to, of course. So, and this also, for example, if you monitor someone's body, it can also give you some information, some really sensitive information about his life. So it's a really critical data. So you have to be really careful on that, because it's a really critical limit that you shouldn't pass, you shouldn't cross. So we have to be really careful on that. And I'm sure whenever you design such a digital twin application, first and foremost, you have to like sign some kind of NDAs and everything in order to be sure that this real personal data will not be used for other purposes. And there will be a limitation to gather the data. This is a really important challenge, since we cannot, if we cannot, the most important data, how we are going to build the digital twin, it's like a trade-off. I mean, if you take everything, you can build a perfect twin, but this is not ethic. I mean, you have to be really careful on how you can adjust and tune these parameters. So this is an issue, actually.
For example, IEEE European Public Policy Committee prepares some statement on AI or some other topics. Sometimes these ethics about medical. I'm not sure about the healthcare, but they are preparing some documents, some concise, short documents to show the statement, position statement of Europe, IEEE Europe. That is why I asked him, maybe I don't know their exact position about that, but maybe such a discussion can be considered in more detail, and maybe they can start such a new position statement work group about that.
Yes, exactly.
Thank you very much. And can we continue the next slide? I have a question about that.
Next slide with the next.
Yeah, next slide.
I am not in the next, by the way. So anything that I'm going to say are not so deep, but okay.
Yeah, in fact, yeah. As I see, this is the first application in Turkey.
As far as I know, it's a really so successful application that we have in Istanbul, actually. Yes.
Okay, you start the application, and what is the most apparent challenge about that? Of course, you succeed very well, but do you see any challenge about, or any future expectation about when you consider
this? I mean, this is not my thing. This is we just went there to see what they did. This is quite a nice implementation of MESS, MESS, like gathering metallic Institute of Turkey. So when you go there, you see such a successful implementation about this MEXT. And for me, I mean, anything that we saw here are really exciting. I'm really encouraging to all of you to go. If you are in Istanbul, you go on. If you can go and check what's going on there. It's really nice, and they are doing a really nice job. So the digital twin part, the digital twin factory, is really impressive. So you can go and see and check how they do this in the real world. The galvanizing line, like the digital factory that you have, all with robots and everything. It's really nice. So I mean, you can always check their webpage and try to see what are they doing. It's really nice. So with ITU, we are also doing some industrial level collaboration, and with several companies and several also international way. They have some good connections. So it's a really proudful thing to saw such nice initiatives in Turkey.
Yeah. In fact, as I mentioned from my PhD, I'm just trying to do some. I was just trying to do some experiments, some implementation about some middleware ROS robot operating system, and it was a bit challenging when we consider multiple nodes. And in fact, even when you consider to use multi-robot system and player robot system, it may have many challenges, and when we consider the building such a system, of course, it may have some other challenge. And I'm really excited about this research, and I hope I can be a part of such a research in the future.
Yeah.
Thank you very much for this great webinar, and I'm just I finished my question, and I cannot see any other question,
Okay, then. Good.
Platforms. Okay. Then thank you very much for this great webinar again. And if you have any final words or advices to our attendees, we'll be very glad to hear that.
I mean, we should all continue to do research in order to improve our technologies. We should be not only in the user side, but also in the development side, and develop new technologies and try to understand what's going on. Always ask us the research questions to understand new things, and then to come up with the novel and solve some novel challenges. This will be my final words. And thank you very much again for this nice arrangement and organization, Ömer. I know how hard to arrange those things, but it's really, you are doing a really nice job. And I'm really following all your activities, and it's really so informative and helpful to all of us. So please continue to do this nice job, and thank you very much for everyone to listen to us today. Yeah, and that's it. Thank you.
Thank you very much again for this great webinar, and we are very glad to host you in this webinar. And dear attendees, thank you very much for your participation. Today we talked with Dr. Berk Canberk from Istanbul Teknik University, Turkey, who is a very great researcher on numerous topics. And you can follow, you can ask your question to him. I may again share the your email. Just
yeah, I can share it again one more time. No worries. So the slides.
I share it.
Yeah. I can also.
Okay. If you have any more question, then you can ask your question via this email. Thank you very much for the participation.
Okay. Thank you, Ömer. Bye bye.
Bye bye.